Okay, so now you should get the message. Right. So good morning. We are in the second three sessions that we are going to share today. Just a little bit of a wrap up with respect to what we saw last, 2 weeks ago. And first, an announcement. I was talking with Dariusz while the others were arriving. The material will be, sorry, will be ready on casein this week. I have had technical problems with the system, and so they are trying to see what is going on so that I can share and liberate the material. If this doesn't happen in the next day, so I will I will send you an alternative address where I will put all the material so that you can have access to it, and then eventually when Casein will be back online, then at least for me, then I will let you know too, so that you have both possibilities to access the material. Anyway, so last week we did quite a big bunch of things. First of all, we remind something that you have addressed in the first part of the course, which were the definition of big data, and particularly we all agree, I hope, that it's not about the fact that volume is an important property of big data collections, but it's more than. There are several properties that have to be taken into consideration in order to make decisions on how we manage data, and then, of course, how we exploit this data. And so something that you have to bear in mind and be comfortable in dealing with is the V's that we have discussed. So remember, volume, variety, velocity, value, and veracity, right? So these are the five main properties. Of course, there are others as we discussed, but these are the main properties that we have to take into consideration when we exploit them to build experiments, right? So we explained last time that, in fact, all the idea, at least for you in Industry 4.0, is that this data will allow you to make decisions, of course, technical decisions, management decisions, and in an integrated manner. And so this is why it is important to profile the type of data that you have and you need to deal with in order to make sure that your experimental settings are pertinent and that allow you to make decisions based on facts, on data, okay? And stop making decisions in an empirical manner and through best practices. Okay? Then another aspect that I touched as a context of motivation is the notion of datification. In fact, datification is the general umbrella that covers this idea that we can digitalize anything in reality in order to process this digitalized data and then make decisions. And also this allows, and in this Industry 4.0, this happens a lot, to create simulations that can also allow us to test in real conditions possible settings that we would like to explore. And this, you have probably heard about digital twins. So the fact of having a digital twin this is possible because we are able to observe, collect, and digitalize huge volumes of data, even continuously, so with a high velocity pace, and have this digitalization of an environment, for example, a workshop in an industrial setting, and then play with the digital twin, either to make online decisions, but also to explore other possibilities. And so this umbrella is called datification, right? So if you want to use the jargon of big data and smart analytics and data science, so datification is an element of vocabulary that's important to understand where do things start from. Then here in this in the bottom of my slide, this is something that we have been moving from the first part of the course, where you studied classic solutions of data, and then I suppose that by now you have finished the hands on Mongo, for example. So we have shown that it is possible to have storage solutions. In fact, the message is that anytime that we collect data, we need to store them, and there are different solutions in which we can store the data, from archiving the data until having more interesting representations, richer representations that can allow us to ask more interesting questions, right? And so you have seen that querying in both relational and other types of stores like MongoDB are ways of analyzing facts. And then we saw that there is this curation spectrum of data, where in classic solutions like the relational model, we have very structured representations of data. And then when we move, for example, towards solutions as MongoDB, we have more relaxed representations of data, but also this opens the possibility to have dirty data, okay? And so there we have to include in the process of querying the fact that either we allow and through querying we filter this data, or eventually we will see today that it is possible to perform a processing, a data cleaning processing, in order to allow to have clean collections that can serve as fuel to analyze them. And so we moved, the last time we saw that we moved from factual queries towards more explorative queries. And we said, sorry, that there are two big families of queries that we can ask when we move from factual towards more knowledge discovery aspects, which are modeling, so understanding a phenomenon, and then predicting the phenomenon, prediction. So these two big families of possible questions that we can ask represent an explorative way of querying the data, okay? And this is the part that we have worked together with me, and that we will like kind of wrap up and have a technical experience on this. Then another thing that we saw last time was the cloud, because the objective of the 2 days that I am working with you is to show an alternative solution to having everything processed locally, either in your computers or either in a IT solution that you would have in an organization or at school. Example with, again, with the MongoDB, you you saw that the MongoDB server that you used, I believe, in at least in part of the practical exercise, is lying on a server at the NCMAC, so at the school, right? And you connect to it, and then you perform questions, right? Other questions? No. Okay. That means that you externalize, of course, the server, but still it is in an organization where you belong to, right? If you do not belong to the organization, you cannot access it. And then with me, the idea is to show you that it is possible to have a harder externalization with a set of quality of service ensured, and that this can help us design different experiments, so data processing experiments at different scales, right? Because of course the experimentation that we will perform on data will start in-house as an in-house experiment, more or less as the way experimental sciences work in the lab. We set the experiment, we figured out which are our research questions, how we are going to answer them through this experimental exercise. And once we are sure and we have promising results, then we start scaling until we move to an industrial setting. Well, this is the same with data. We are going to start in an in-house setting, and then little by little we will be able to move towards large-scale environments, and the cloud provides all this spectrum of scale. Okay, and so this is the message that I want to pass. Of course, later on during the course, you will continue working in your in-house solution with the R Studio, but and eventually connecting to MongoDB. But anyway, it's important that you see that there are other possibilities when you will work in an industrial setting, right? And with that, what we did at the very last part of the third session 2 weeks ago is that we introduced the notion of data lab, right? And we said that a data lab will provide a set of services through an stack-oriented architecture, where we will be able to deal with our data collection, stack them, version them, etc., so that, and eventually share them with a set of people in order to later on be able to use them in order to drive experiments, right? And that was the last part, the very last thing that we did last time using the Kaggle solution, right? Do you have questions until now?
Good morning. So you said the last lesson will be, the recording will be on Kazin this week?
I mean, yes, this week, or I will, as I said, I will give an alternative address where you will have both a YouTube video with the video we have been recording, and also the material.
Okay, thank you very much.
You're welcome. Other questions before we move on? So this is this is your map, okay, to know what you have to bear in mind of all the things that we have discussed until now. And then, well, let's move on if no questions are here. This is something that you have seen in previous sessions, particularly with Professor Bovino. The first thing that we start with when we start dealing with data collections that we are going to explore an important question that we have to answer is whether we will leave the data on the raw state, or are we moving and are we performing two types of operations? First of all, a restructuring part, right? Do I accept raw data, for example, as tabular representations, or am I going to anyway structure them differently so that I can feel more comfortable, or so that the tools that I'm going to use can be applied on top of the data? Okay, so the approach that you have seen until now is that we are going, in fact, to play with the structure. Okay, so the fact that we upload from, for example, a JSON representation, as I believe that you have in Mongo, then we can or you have tables, right? So you start with tables and then you move to JSON, for example, in MongoDB. Tell me if I'm saying something that you do not have any idea that happened, okay? So this transformation, in fact, is more complex than moving, for example, from a tabular representation towards a document-like representation. In fact, it is possible to make decisions on whether we are keeping tuples, very simple data structures. We move to documents, as you did with MongoDB, or you move to more complex representations as multidimensional representations. Okay, so in the course, I believe that this decision making you will not be so evident, but it is important that you bear in mind that this is the first decision that you will have to make when you decide whether to move from raw data into some specific representation. Okay, so of course, maybe you directly will not do this, but together with an IT group, you will have to decide this. And your decision is whether you are not losing information and whether the eventual tools or eventual reasoning that you have to make with respect to an industrial process or a decision within industry will not harm the new structure, will not harm your the questions that you will ask. Okay, so then how you do it, this is a problem of IT. Okay. And then, well, this is something also important. I believe that in the course with Professor Bobino, you saw that there are different types of stores that are available, and then the decision there is also more or less an IT decision, but then you will deal with that. So, for example, in the project that you will perform during, I mean, for this course, you will have to make a huge decision. I think that we are moving towards the fact that you use as much as possible MongoDB in order to then perform your exploration tasks and the other tasks that you will be asked to do to complete the project that will cover the whole course. Here, for example, the decision is to keep as much as possible data on MongoDB and then perform other analytics in R, right? But this is not this is a pedagogic decision that we are making, but in fact, the decision making to be done is larger than that, okay? So that's, or you can even decide that you are not going to use any store. You keep your data in an archival manner, as we will see today in Kaggle, and then you perform your experiments and the data lies there as a data collection. Okay, so you will see, I suppose, that either during the exam or during the discussions when you will present your project, it is important that whether you decide to go through Mongo and or not, you have to argue about this decision, okay? So elements of decision making is, what you have to know is that when we ask modeling or prediction questions, as we said last time, we will be performing experiments, and almost all models, numerical methods that you have the habit to use, statistical models, even eventually when you will see regression and other types of models, all these models need the data to be in main memory, okay? So even if you use a store, you extract the data from the store and this data lie in memory, okay? Then you process them. And the question is, then what is the interest of having the data, for example, in a store? Okay, so this type of questions, well, I believe that you have discussed with Christophe. These are the questions that you have to bear in mind in order to argue for the decision of using or not, or the interest of using, for example, MongoDB for your projects or not. Okay, so that's an important element to have. So I'm going to skip this because this you have seen before, and I'm going to focus on this. So last time we saw that in the experimental way of thinking, if you wish, in fact, we are not going to express a query once in one shot and expect a result. We are going to perform a pipeline, a workflow of operations that will allow us to answer a research question. So first thing, never forget that without a research question, there is no point of doing an experiment. Every experiment is adapted to answer a research question, and not all the research questions possible in the world, just one, okay? So normally, as we said, there is a first part that we will start having a hands-on that. Is I start from the raw data, so the data collection like the one we saw in Kaggle last time, and then we have to understand its content, okay? I mean, the hypothesis in experiments is that we can have few knowledge of the conditions in which we receive the data. Of course, we know that, I mean, the topic associated with the data, but we never know in which conditions we receive the data. And which are these conditions? In fact, these are mathematical properties of the data, okay? And so the very first step towards being able either to model or to predict is quantitatively understanding the conditions in which data arrive to our hands, okay? So first of all, the very first profile that we have to make is a statistical quantitative profile, which means evaluating metrics, statistical metrics on the values stored in our data collection. You all know that's something that you learn in statistics, that, for example, computing average, computing many statistical measures require the data to be cleared of outliers, of null values, and of missing values. Otherwise, the metrics are very sensitive to these kind of problems in the data, and their representativity is not very trustable, okay? So before we perform the quantitative profiling of data, we have to see the quality of the data in terms of whether there are missing values, null values, and outliers, okay? So first acquaintance towards the data collection is this quantitative quality of the data. Once we determine this, the first decision that we have to make is how do we get rid of dirty data? Okay, and there we rely on our statistics knowledge in order to make to make this decision. Imputation is the name of the action, okay? But there are many different ways of imputing, for example, missing null values and outliers. So the first decision that we make is which is the strategy that we are going to adopt in order to impute problematic values in order to have a clean data set so that we can perform its quantitative profile. Okay. So the other aspect is, okay, so now I have it clean. I got rid of my missing values, etc., outliers. And then still there can be a little bit of problems. For example, imagine that we have a bibliographical data collection, and that the name of the authors can have the following problem. Me, for example, I can be Genoveva Vargas or Genoveva Vargas / Solar. Or if I am in Portugal, for example, Genoveva Solar. Okay, so all these Genovevas are me. Okay, so first thing that someone exploring the data has to say that instead of having all these different elements as variable elements in the data collection, we can clean the data collection and say that every time we find Genoveva Vargas-Solar, Genoveva Solar, all of them will be Genoveva Vargas-Solar, for example. Okay, so this type of cleaning is important, again, because otherwise our eventual analysis can have a problem. Then other aspects that particularly, this I think that we discussed last time, is that, for example, when we apply regression, the regression model requires the data to have specific mathematical properties, and particularly the data must be normalized. Okay, and in many mathematical models, normalization is an important element so that we can apply the models. So we need to normalize, and then eventually we can also, for example, when that's another problem that we learn how to deal with in our engineering mathematical knowledge, is that when you have observations with a lot of variables, you can reduce the number of variables towards those that really affect the aspect that we want to address. And so this variables reduction is another way of preparing the data collection. And then again, in statistics, we learned that it's possible not to deal with the whole set of observations, but rather have a strategy to choose a sample of data on top of which we are going to perform numerical analytics, statistical analytics. And so again, it is important to have a strategy in order, if we decide that we are not using the whole data collection to perform our analysis, to select a sample according to different criteria, okay? So all this, as you can see, has nothing to do with artificial intelligence or anything. It's the knowledge that we have and that we acquire in our statistical education that is applied in order to understand the conditions in which we receive the data, to answer one very important question, which is this data collection enough to answer and usable to answer my research question or not? Do I need to complete the data? Do I need to change my collection? Because according to its status, it cannot be used in order to answer the research question. So this is the question that you answer with respect to the first part of an experimental data-driven setting, right? So, and this you will see in many situations, particularly if you eventually decide to focus on data science education, is that many people come and say, okay, I have my data here. What can I do with it? Meaning, which are the type of questions that I can answer with this? Or I have this question and I have this data. Is it possible to use this data in order to answer my question? So this set of tasks will allow you to answer this very first question, okay? And of course, here you see that you rely on also on visualization techniques in order to better approach the statistical results that you perform across this set of tasks that are called under the umbrella data exploration and preparation. Okay, so this is in some minutes we will see this is the first type of activity that we will have to we will perform today. And this is, for example, again, I refer to the project in the course. This is the first step that you will have to perform for understanding the data that you will use in the project. I'm sorry. And once you have done this, then you can do many different things depending on the research question that you want to answer, right? So if the question is of type asking for or digging into insight, then you will use all possible methods that can allow you to answer this type of questions. Or if you are predicting, there are other set of tools, mathematical tools, that will allow you to do this. So first decision, once you have your research question, is to decide whether it is an insight or a foresight research question. And according to this, you are going to choose the models that can allow you to answer this question. And every single model has its requirements, its rules of use, okay? So you have for every model the rules of use, and the rules of use often implicate the data, okay? So as I said, for regression, you have to have normalized data, and the variable that you are digging into must be linearly independent of the other variables, for example. So you have to do this testing for using these particular types of models. And if you use others, again, you have to know which are these rules, such that in the first part of this set of activities, now you prepare your data in the sense that it can adhere to the restrictions of use of the type of model you are going to use. Okay, many of them, for example, you will see in the further in the course with Professor Jolie that regression, for example, needs two steps. One is training the model, and the other is testing the model. And for that, you have to fragment the sample that you prepared here, okay, into 2 or into 3, depending on the type of model that you use. Then you use your model, and remember that every model needs assessment, meaning determining the error that is implied with respect to a baseline, and then ablative analysis in order to understand that according to the results, the degree of precision, etc., depending on the set of scores, depending on on the tool that you use. And then you validate, and then you see whether you converge or you have to go back again and again a lot of times, such that you get a reasonable result. And who says what is when do you converge and when do you have a reasonable result? An expert. Okay, so nobody mathematically can define whether a solution is the acceptable solution. It is through the scores and the error analysis that an expert will say whether the result answers satisfactorily the question, the research question for which you implement all these set of tasks. So this part we will not see with me. This part will concern the part of Professor Jolie with regressions and many different tools that you are going to study further. Okay, so in this course, we are going to see a lot about data exploration and preparation in order to prepare the next part, which is how do we deal with these aspects. But anyway, as I insist, you have to bear in mind that this part is the second step out of this, and that all the two parts are represent an experimental design. Okay. Now, since we are interested in preparing data, so there are 4 aspects to consider. First of all is obtaining the data. Okay, so read from a file, or how are we going to obtain the data? In the project, we provide you with the data. In the exercises that I am going to work with you, to share with you, I am also giving you the data, but anyway, in real conditions, you have to determine where you are going to obtain the data. Then, of course, you need to parse the data, meaning that you have to know the format, okay? Without knowing the content, you have to know the format of the data. Then you are going to perform, as I said, a set of tasks in order to clean it, and then decide whether or not you are going to give them another structure. So if we come back here, until here, but at least here, there is the data structure that you can decide whether you use the data structure that comes from the raw data or you already transform them. Again, referring to the MongoDB activity, in fact, we start here and then we transform them into JSON, right? The document representation. And out of this, you can start performing a quantitative profile. Okay. The set of questions that you have to perform in the hands-on, the Mongo hands-on, some of them are related to not exactly quantitative profiling, but exploring whether there are nulls, whether there are missing values, extracting only those elements that really have values and not missing values, etc. So this can be done, as I said, through a querying language or with other tools, as we will see today. But until now, if we think about MongoDB, we will be here. Eventually, we could even touch this part. Okay, only with queries performed by Mongo. So in your project, you will have to decide whether these type of activities you perform using queries on MongoDB, or whether you use alternative operations like the ones you have in R. Okay, so that's the first thing that you will have to decide with respect to the project, but you are here. So now I'm going to skip this because this is the description of the things that we are going to do, but it's better that we see them directly online. So was just a recall, prediction, or classification. But before that, we need cleaning and preparation, and this is what we are going to do. So just to put you, to remind you where we are in terms of, now it's technical, okay? So I said theory, now tools. You have 3 families of tools today in order to play with experiments, data-driven experiments. Either an IT team prepares a virtual machine with tools that are necessary to play with the data in terms of experiments. And there, well, you will have many different solutions. As you can see, for example, here, at this level of this stack solution, you would have Mongo, Oracle, etc. And before you can have storage solutions, infrastructure solutions, and all this is prepared through a ready-to-use virtual machine, where you will have the impression that a whole system is ready for you to be used for playing with data. On the other side of the spectrum, you have when your type of analysis is much related to machine learning and artificial intelligence, even if other models can be used, then you can have machine learning studios or services where they provide you with the analytics tools together with storage and parallel processing tools. As we saw in the last sessions with me, I explained that big data collections are those that require programming models that can deal with greedy algorithms, those that consume a lot of resources and big volumes of data, right? So we would need the right platforms in order to perform parallel processing. And so these studios provide with the right tools in order to perform parallel processing. For example, you studied with Professor Bobino MapReduce. So there are environments that can allow you to write programs that can be executed on the MapReduce programming model, okay, execution model. And so these kind of tools provide you with all necessary tools in order to perform this. And normally, since this requires computing resources and storage resources, normally these solutions are externalized on the cloud. And major cloud providers have their own solutions with this type of setting. Here you have the Azure one. And in the middle, when we want to work in-house, there are a certain number of tools, as now you have installed our studio on your machines. So this type of environments allow to have in-house experimental settings. And sometimes when we do not want to install anything in our computers, we can also have an externalized provision of these kind of platforms that can be accessible on the web, first of all. And also that can allow us to access to some hardware that can help us to, of course, work in-house, but at least with a more realistic setting in terms of scale. Okay, so we can have different hardware, different accelerators, in order to do more realistic tests with respect to our machines, right? So if you are very extravagant and that you have a very developed machine, or if you are players, maybe you have a very powerful machine, but normally people like me, we have machines that of course are I mean, can be used but do not have accelerators, etc., in order to play with large-scale solutions. And these environments provide us with that. And so we will have today the experience of using these environments. Okay, so let's say in-house middle-size settings for experimenting with data. I had a nice animation that I didn't use. Well, okay. So for the time being, well, you have prepared R for almost the whole part of the course, but I thought that it was also important to have a kind of Python experience so that you can compare also and see the benefits or not of these two tools. So it will only be with me and today that you will have a look on Python if you are not acquainted with it. But this will complete the vision of maybe the two main languages that are used in data science experimentation. Both R and Python are very popular, without forgetting that MATLAB is there too, okay? And I believe that many of you have the experience of using MATLAB. The only thing that I will say with respect to the three of them is that you have functions ready to use in order to process data in mathematical terms, in order to drive models, etc. You have more or less the similar set of functions, including today artificial intelligence models that you can apply as part of your experimental setting. The other thing that I will say is that with R and with Python, together with externalization, you can play also with parallel programming, okay? Or not, as we will see today, but that's so you can have the backend infrastructure that can allow you to also program in parallel, whereas in MATLAB has parallel solutions that can be installed on clusters so that your analysis can be performed on a cluster manner. But this is the version of MATLAB that allows you to do that. Whereas here, it's more a configuration decision that you make in order to go for a parallel programming or not. Okay, so that would be the things that you have to know in order to compare. Remember that I mean the principle and the vision of the 6 lessons that I am teaching is a lot of technical decision making, a lot of comparison, so that you can have this contextual vision of the tools, the languages, etc., externalization or not, and that can complete the rest of the course, which will be done in R in your machines and focusing on the types of analytical tools, mathematical tools that you can use in order to drive knowledge, right? To model and to predict. That's the view of the thing. So do not build this in mind so that you understand what we're doing. So in any case, as I said, for one or the other, when we do data science and we perform experiments, at the end of the day, we need a programming language, okay? So here you have the alternatives. And then when we talk about Python, we have 4 main libraries that are available in order to perform experiments. As I have insisted a lot, many of the data that we have access to, in fact, are tabular representations. And if we make a big jump, theoretical jump, we can consider, at least from a computing science perspective, that tabular representations are matrices. Okay, so many of the analysis that we will make is done by playing with matrices. That's first thing. And the other thing is that many of the research questions that we ask in engineering are related to linear algebra, okay? Both in classic solutions and also many artificial intelligence algorithms in the inside, they play with matrices and with linear algebra notions. So playing with matrices is super important, and that's something that we know because of our engineering education, right? So it's not me that I'm going to convince you after, I believe, 4 or 5 years of studies that matrices are a key element in our education, right? So Python provides a library that allows us to have basic operations on matrices, and particularly very useful linear algebra functions. Okay, so that's NumPy. Then again, another aspect that we study in our engineering education are numerical algorithms, right? So there is SciPy, which is a library that contains, I mean, I would say that almost all the most popular numerical algorithms that we use in engineering, together with other tools, including signal processing, optimization, and statistics, which again is something that we use a lot in engineering. Then matplotlib, often when we do statistical analysis, we rely on plots that allow us to visualize in a friendly manner the results. And so one of the very basic libraries, there are other more fancy libraries, but the very basic is matplotlib. Then, as we said, today, new techniques coming from artificial intelligence are applied in order to answer research questions through data analysis. So the library scikit-learn has, again, huge number of models that for classification, for clustering, dimensionality reduction, which is a very important aspect, selecting models, preprocessing, and also a lot of regression. So the equivalent you have in R, and as I said, regression will be an important part of this course, and so you have all necessary tools for playing with regression in scikit-learn. And then this is more for structure. Since we have said that a huge bunch of data collections are collected in the form of tables, of tabular representations, this data structure is very popular. And so the idea is to have a library that can allow us to play with tables, okay? But not in the linear algebra notion, but structurally with tables, okay? So we will remind which are the operations on tables in a minute, but well, you have this tabular, this library with all the necessary tools in order to play with tables. You have the similar solution in R. If you are acquainted with R, there is a popular data structure called data frame. So the data frame is a tabular representation in R and in Python, and you have in both cases the functions and tools in order to play with this. Okay, so it's data frame. if you are acquainted with R already. Now, that's the programming language, okay? So let's assume that we have chosen our programming language, then we need an environment in order to run our programs. And so, example, you have your R Studio where you can run your programs. This studio is an integrated development environment where you have everything to write your programs and to run your programs and see your results, okay? So this IDE, the so-called IDE, so has, as I said, the right tools for doing that. And in the case of Python, an example of the environment that contains the libraries necessary to play with Python is Anaconda, okay? But then the question is whether we install Anaconda or not. We will see that again with my externalization approach. There is no need for doing that, but it's important that you know. Now, again, either I install them on my computer or I can access them through the web. So the idea is that we are going to use a web integrated development environment. And then the unit of construction of our experiment will be the notion of notebook, where if you are acquainted with R, you know, but a notebook is a structure where that is composed by cells. And we can have code cells and textual cells. Why? Because we are reproducing the way we perform experiments in experimental sciences. I suppose that in your undergraduate and at school, when you did secondary school, for example, we used to go to the lab and they taught us to have a kind of log of the experiment, right? So we described the experimental setting, and then we said, okay, the process is like that, and I observed this at this moment of the process, etc., and so on and so forth, until we concluded about the results of the experiment. And all this was the report of our experiment. Well, this is the principle in a notebook. Step by step, we will perform operations, which are the phases of our process. One or several operations define a phase of our process, and we will say the objective of the phase and the results we observe within the phase and after the phase. And if we have to decide, for example, about parameters or some specific operations in order to perform this phase of our experiment, we note them such that eventually us or someone else can repeat, reuse, or reproduce our experiment. Okay, so this is the spirit of the notebook idea. And so we need an environment that can deal with the execution of these notebooks. In the case of Python, there is an interactive console named Jupyter. Okay, so we are going to use Jupyter notebooks in order to play with our experiments today. Okay. And well, I suppose that you have seen this because R is very similar, but so this is an example of a Jupyter notebook. This is a textual cell. This is a code cell. And this is what we see as result. And so step by step, we design our experiment. We perform the operations and we see the results, we comment them, and we continue until we obtain some results. Again, just we are really now moving towards the technique. So remember that this is something that I introduced last time. So now You can have also Jupyter on your notebooks, but I mean in your PCs, but we are moving to the cloud. Remember that the cloud has this architectural reference. You have access to hardware resources in the form of service. You have access to platform, and you have access to software. Okay, so we will be moving across these three layers in the solutions that we will study today. Now, before I open the floor for questions, behind the scenes, this is something that I presented for the data lab, but I am reusing it to such that everyone has in mind what we are going to do. Remember that I said that we are using two clouds, okay, Google and Azure. Okay? In Azure, we are using a service called GitHub that allow us to version code, okay? And me and my team prepared, in fact, a set of data that we are going to use in the experiments. So as data science has become popular, many, GitHub also hosts experiments and data so that people can also manage their experiments. And this is why we decided to use GitHub. So, sorry, since we are talking about the cloud, so we have, remember, access to platforms. So we have disk allocated for us in order to store data or code. We have a file system so that we can interact with the data stored in some storage support. This is platform. And then we have the GitHub interface and the GitHub application that allows us to play with all this in a very friendly manner. And this would be software as a service. And of course, we can install a GitHub app on our computers, and this GitHub app is a software as a service. Okay, so we have the other side. We will be using Google Cloud, and Google will provide us with infrastructure as a service in the form of different processing units, CPU, GPU, tensors for matrices, so different hardware that we can use in order to run our programs. We will use also disk, so storage. We will have a file system to go through this. This is platform as a service together with compiling or interpretation environments. Today we are using Python, but it is possible also to use R. So R, either R or Python would be platform as a service elements that Google Cloud provides. And then we are using, in fact, we will compare two solutions. One is Kaggle that we have started to play with last time. And I will also show Google Colab so that, again, you can see both of the most popular tools used in order to perform experiments today. Okay, so the idea is also that you have this vision of more or less the state of the art of the practice of data science, at least until now. And cool thing is that the only thing that we need is a browser, so we will not have to install it. Last time we saw this, I'm not going to go through again. So if you have not created and played with this together with me last time, so we will have like a moment in order to allow you catch up. and then move to the experimental setting, okay? So this is the moment to ask questions before we move to hands-on.
Yes, I would like to some precisions about parsing. Sorry, parsing. When you talked about parsing when preparing the data, I didn't
Yes.
quite catch the purpose of this parsing.
Parsing is intended to determine which is the structure, the format, and the structure of your data.
Okay.
Right, so when you really have to think that data come in a very raw format, so even signals, okay, or yes, very raw format, and then you have to go through it, and this go through it, so the content is called parsing.
Okay. Okay.
Mm-hmm.
So okay. So it's understanding the structure means
The structure.
have we got sets of data or tables or whatsoever?
Whether the structure and also if there are types, the types, whether
Okay.
it is floating point or integer or characters.
Okay, I see.
Mm-hmm.
Yeah, I didn't get well the difference between Azure and Google Cloud.
There are two solutions. So there are two cloud providers. One, Azure is from Microsoft, and Google Cloud is Google. And we are using different services on them. In Azure, we are using a solution called GitHub, among many solutions. And when we use GitHub, I did the parallel on the 3-layer architecture that I introduced. So storage, platform, and software. And this service is intended to manage versions of data and code.
Okay.
Right? And on the other side, we have another company providing also cloud services. And in this company, we are also using infrastructure in the form of processing units and disk, on platform, and on software. But these are two different companies, and the kind of nice thing that we're going to do is we are going to communicate the cloud from Microsoft with the cloud of Google to extract something and then work with it. Was it less dark?
Yeah, okay. Thank you.
Okay.
I have a
Hi.
request.
Hi.
Can we go to the slide of the no SQL just to see something?
Can we consider
No, can we go to the slide of
where
no
there is no
SQL?
SQL?
Yes, please.
Let me, well, I'm going to do this otherwise. To this one. This one or the previous one?
No, there was one that said no SQL.
This one?
Something that they cannot queue or something. If not, it's fine. I will check after.
Well, I'm
It was
showing
after.
After.
Oh, that one, the 15.
15. Right.
Yes, thank you.
So the idea here is that in the part of Mongo, you could answer factual queries. That's all the set of queries that you have to prepare for the hands-on of Mongo. These are factual queries. You do not go beyond the content of your database. And the spirit here is that you are going to produce new knowledge using the data, but that is not contained in the data.
Super. Thank you.
Mm-hmm. More questions? All good? Okay. So before we do a break, what I'm going to do is, for those that didn't do, they can catch up, and for those who did, that you recall what we did on Kaggle, right? So I'm going to do the following. Well, first of all, I want to close a lot of windows that I have that I don't need, and I'm going to put on the chat two pages that we need in order to perform the hands-on, right? So this is the first one. This is my chat. It is my chat. No, it is the question answer. Chat. So this is a first page that we need. And the second is, but that you already have, is Kaggle. If someone didn't make it last time. So like on TV, we need these two pages to be open. Okay.
Sorry, can you get back to the first one?
The first one is this one.
Oh,
You have the link on the chat.
the chat. Where's the chat?
The chat is on the bar that you have on top of Zoom, or Want to move
It's the first link before Kaggle, right?
Yes.
Okay.
Mm-hmm. So the first link is data-centric smart experiments.
Yep. Okay.
Right. And the second is Kaggle. Right. And if you remember, the last time we worked together, we saw data sets, which is the data lab of Kaggle. If you go to your work, in this button, you will find, for example, me, I created this data set together with you. So if you did the manipulation together with me, you should have a data set that you created. Well, me, I have a lot. You only one that you created in the last session. Now, for those who didn't, let's do this together. Just give me a second that I'm going to give you a third link that we need. So sorry for this going back and forth, but you need this. So I'm going to reproduce what we did last time for creating a data set, okay? So those that already did it, just watch. And those who didn't do this, do, because then we are going to use the result for the experiments of today. So you're going to click on new data set. So you go to data sets, you land in data set, and you say new data set. Once you click on this new data set, you land in this formula. You are going to go to link. Well, remember that here, if you have the data on your computer, you would drop it, right? But we do not have it in our computers. So we are going to go to the link option and say that we are going to import from GitHub. Remember my back of the scenes, we have the data on GitHub, so we say that we are choosing GitHub, and the last link that I put on the chat, you have it here. So here is the address. Well, here's the name of my colleague who prepared the data. So here is the address on GitHub that contains the data that we need. Okay, this address is on the chat. And then if you click on continue, you land here. You have to name your data set. We are going to keep it private, but you can decide whether you put it public, it doesn't matter. So, this data set. And then you click on create. If you click on create, well, it creates it, and then you go to data set. And you have this. And of course, I'm not going to go through all the explanation because, well, we did it last time. Then you will have the video in the very last part. I explain all the contents of a data set. Okay? So I'm going to give you like 10 minutes. So we come back at 9:30. So just the time to grab a coffee, and that we can start the real experiment, the first experiment on data preparation using the data set that we have created.
Okay.
Okay, I'm going to pause the registry. Wow. So I let you go to this page, and then we will be going, as I said, back and forth between the two, between Kaggle, our notebook, and this page. So the first thing we are going to do is do data exploration and quantitative profile, okay? Reasoning about the quality of the data in regarding null values, missing values, and outliers. I don't think outliers will come later, but at least these two. Okay? And with that, I will profit to remind you the different operators, structural operators that can be performed on tables. Okay?
Sorry, Genoveva?
Yes?
I got one page, but not starting with getting started. I got my page is starting with hands-on. Wait.
I'm going to put the address again, maybe. What did I do? Wait a second. Yeah. I always forget that I'm sharing the whole. Here in the chat, you have the link to
Ah.
the right.
Yes.
Mhm.
And a new one. Okay, this better. So there are 2 pages finally, or
Well, the first one is the general one where you have many exercises,
okay.
right? And the second is, in fact, I am in here in exercise 1.
Okay.
Mhm. But in fact, this is the page that this is the site that has the material. But since I'm using Casein, I will put everything there,
Okay.
and if not,
Okay.
we will use this site.
Okay.
That's the idea. So everyone is fine? 2 pages ready?
Yeah.
Okay. So material, we have our Jupyter Notebook server running on Kaggle. We have the Python libraries there because there we have everything necessary, and we will use a CSV data collection. We will see in a minute how. Now, the first thing that I will do is give you the principles on how to use data frames in Python through the library pandas. And once I will do that, then we will move to the actual experiment. So what we are going to import is pandas for dealing with tabular data, NumPy for dealing with, well, we will use statistics essentially, and matplotlib to plot our results. In Python, I believe that in R2, we can put associate an alias to the libraries to avoid verbose code later on. So for pandas, I'm using PD, for NumPy NP, and for matplotlib and particularly plots, PLT. Okay? This is what it says. All this said. So I'm going to copy this and run it here. So I'm going to say that I need code, but I'm going to run this to show you eventually something. So in my new code, I'm importing my libraries. And nothing happens apparently because it's just importing libraries. Now, in pandas, the unit of construction. So we have only one unit of construction, which is the data frame that represents a table. Tabular data. That you know, if you have been using R, you know this data frame story. Now, what I'm going to show is I'm going to define by hand a data collection, a very small one, so that I can introduce, as I said, the properties of data frame, and then we move to the real data. So here in Python, there is the notion of dictionary, which is a record. And so I'm saying that I'm defining in the variable data these elements. So this record that contains an attribute year with this extension. So I'm interested on the years 2010 to 2012. I'm interested in something that I call a team and a set of strings representing those teams. I am saying that I'm interested in wins, in draws, and in losses, number of wins, draws, and losses of such teams with these values. And this is my little tiny data collection. And then here I am going to create a data frame, so a tabular representation with the content of this variable data, which I have defined here. And I'm going to say that the columns of my data frame will be named after these names, which I am reusing from the original names. But you can say T1, T2, T3, T4, or whatever. this is just an mnemotechnic strategy to associate what the data initially have with my new data frame. So I'm going to execute. So when I want to see the content of a variable, I write the name of the variable, and I can see the content. Now, what is interesting is the characteristics of the data structure. Well, of course, it's a tabular representation where columns can be named, and columns are tagged with an order. The records are tagged with an order. So if I'm using the relational vocabulary, these are tuples. If I'm using the programming language vocabulary, these are records, right? Every row is a record. And so records have an index, but the index doesn't make part of the data structure. The actual data structure is the columns and the rows. In the relational jargon, this would be the schema structure, and this will be the extension.
So, Genoveva, how did you get the visualization of football? I didn't follow.
You only, since football, the content is contained in the variable football, you only say football.
Ah, you push a new code to do that. Okay.
Yes, you need that.
Okay.
Here you are saying that you want to see the content of the allocation of this variable.
Okay.
Mm-hmm.
Like interpreting the code.
Mm-hmm. That's good. Yeah, that's the idea. I mean, you will see that all the code is given, but the idea is that we discuss together, we interpret what is said.
Okay.
More than learning how to program in Python if you do not know.
Sure.
Mm-hmm. Okay?
Yeah.
Okay. So here you have the explanation, okay, of what I have said orally, but if at some point you go back to the site, you have this. Now, there is nothing to hand in because we are doing this together. So I'm moving to section 6, which is the actual experiment. So the data that we are using is intended to help us answer the following research question: is whether it is possible to have a comparative analysis of the investment done by European Union countries on education. That is the research question. So I'm going to write it here.
Yes.
I'm going to create a markdown. And then I want to say research question. What to have a comparative analysis of the investment of on education by European Union countries. And here you can have like, I profit from to tell you about Markdown, you probably know it, but here I can say that this is bold, that I'm going to put this in Italian, and then I can add images and etc. So this is like.
Yes, this is quite powerful.
Yes, it's nice. And you can also, the interesting thing is that if you have formula, it has a possibility to write actual formula. So. And in order to answer the question, we are using a database coming from Eurostat, which is an organization that provides a lot of data regarding many analysis, economic and social analysis from the European Union. So it provides educational indicators for funding indicators for member states. So here is what I'm reading. Now, it is important that we know the format. So we know that it is a CSV file. And if we go to the data lab and open the actual file, we will see two things. We will see, of course, that it is a CSV file, but what is interesting is which is the character used in order to divide the tokens. Okay? And so it's a comma. So this is record by record, and then we have to see this, and this, I don't know if you remember, but if you don't remember, let's go to it. I go to data sets. So here you have the data set that we are using. And at some point it is here, no, it's here. So, sorry, let me go through the. At some point, sometimes, but not here. Sometimes it says whether they are separated by comma or by semicolon or others. But anyway, the idea would be that we have a look at here in order to see general characteristics of the collection, so that we can then make decisions on the code. Okay. Right. So we are going to open the file. So we are saying here that I am going to read, well, I'm using pandas. I'm going to read a CSV file located, we have to change this, okay? But located in this path, that the values are separated not by comma, in fact, by semicolon, and that we are going to name the columns as this. Okay, how do we know that there are 3 columns? Because we went to the data lab and we saw that the file contains 3 columns. Now here, in the actual data collections, these are the names of the columns, but again, here I chose to name them the same way, but we can decide to name them otherwise. So I'm going here. Now, this is not the right path. In order to get the path, either you use the information that you generated here, or either you go here and you say copy the file path, and then you paste it here. But not like that. Okay, so now I have the right path. And well, here, these are 2 lines. So this is the opening the file and putting the content as a data frame here, and then seeing And this is the second line, which is the content. And then I run. I have a data frame with my 3 columns, and it's tuples. Already now, and I know that it contains, in fact, 384 rows, and that there are 3 columns. Well, it doesn't show the whole content of the data frame. I have to operate on it in order to see all the parts. But note that already here, I can see that my data collection is not clean, okay? So remember that, of course, we want to answer the research question, but the first question that we answer when we start exploring the data set is whether this data, in which conditions are we receiving the data set, and whether the data set can be used to answer the research question, okay? So all the operations that we are going to perform are intended to allow to say whether the data collection is adapted to answer the research question according to its question. Now, I'm going to write here to say operators on table. Selection, rejection, now, you certainly remember the vocabulary that if you have studied relational databases, you remember that there are at least 2 languages that we learn: data definition language and data manipulation language, and of course the query language, okay? When I create a table, I am using the data definition language. Okay. Now, in the next examples, where I'm going to put that this, we are going to tables query language. So now we are going to study the operators that we can use in order to explore the content of the data frame that we have defined. The first thing is that to know is that I have different selection operators, okay? In SQL, I only have 1. Here, I have 3. I can say, remember that my data frame is called edu, which is the thing that I created here. And I can say that I want to see the head of the table. First selection. Remember that selection operators is getting a subset of records tuples of the table. So here I get the 5 first tuples of my table with this selection operator. I can also see the tail, the 5 last tuples of my table. So for those that are following, I'm here, right? Before I say describe, I can also say to select, for example, from row 10 to row 14 of the table. Remember that in any programming language, etc., it's open, an open interval. So it's from 0 to 4. So 14 is not considered. So 3 selection operators. So anytime in R or in the next language that will be invented in the next months, when you deal with tables, you have to, first of all, have a look at the commands you have for data definition language. How do you define instances of the table? And which are the characteristics of the table? Structural characteristics of the table. Second, you are going to see which are the operators for querying the table. Normally, since there is already a set of families of operators, you have to see which are the selection operators, like now. Next is which are whether there is projection in the language. In fact, there is here in pandas, Python panda. So I want to put here what I can say that I want to project only the attribute value of my table. So I get the content only of the column value, and it provides me with interesting information. I know that the column is called value, but I already knew it because I had asked for it. It says how many rows do I have? And it also has a description of the type. Remember that in computing, the representation of floating point values is very important, because if we operate on them, we can eventually have precision problems, okay? We perform all functions on them. So here the representation is 64. So it's a name, the size of the word, internal word. And then I can also combine. I can say, the lock is not longer needed in the current version of Python. I can say that I want to select this rows, from 90 to 94, and that I only want to see, to project in 2 columns, time and geo. I need to say that the new result is a data frame, and this is why I need these 2 additional brackets. So from what it says is from this new table, I am projecting these two columns. And so I have these two columns, and here you have the index. But remember, the index doesn't make part of the structure. You only need it to select. And I think that I have this. I can select and project with a selection condition. So I'm going to write here, combining projection. So here in fact, note that I have two selections. I'm saying that I want to project on value. And here is projection, combining selection and projection. The right thing to say. So I am projecting on the column value, but only those elements, those rows, where value is bigger than 6.5. And from this result, I only want to see the tail. So all the values are higher than 6.5 in the column value, and I'm only selecting the tail. So if you are acquainted with SQL, you should, it should wake up the worm in your brains, and you can easily make the association. Now, but what I said is that what we want to do, in fact, in preparation, here I'm just showing how to explore, right, the data collection. But the thing that we want to do is start profiling quantitatively the content of the collection. So I can have a first view of its quantitative profile and say the following. This function, in fact, generates a set of statistical metrics on the row collection. Remember that here I saw that my collection is a little bit dirty. But despite I'm just having a first approach and trying to figure out of the numerical values, how does the content looks like. So despite the fact that I have null values and other missing values, I can say the following. Of course, on the columns that are numerical, I can count the number of values, different values on time and value. I can perform the mean. So in average, we have a lot of data from 2005, from the year 2005. I can compute the standard deviation, and I can also compute the minimum. For example, the earliest data that I have in how do I say this? In time is 2000, and the maximum is 2011. So this is the spectrum of data that I have regarding time. And then the quantiles. So this is the first statistical profile, right, of the raw data. But for example, the mean and the max are already interesting. So I cannot do my comparison. I mean, the comparison will be done between 2005 and 2011. Then I will see whether it makes sense to consider all the years or not, depending on the data. And this is why this thing is interesting, right? So I can start determining to which extent I can answer my research question. So the comparison will be done potentially between 2005 and 2011, and then potentially the years that might be more interesting to have access to. Well, I have to decide whether 25% is reasonable to perform an analysis on 2002 or not, and or whether I just keep 2005 or 2008 only, and compare only on that year, okay? So that decision, of course, comes from our knowledge on statistics, but it can also come from the experts that would be asking the question and make a decision on which are the years that we will consider. Now, but as I said, an important thing to do is know the quality of the data with respect to null and missing values, okay? So the first thing that I would like to do is see the null values that exist in my data collection. So I'm going to do the following. Sorry, I didn't copy this. So here I'm asking more or less what I did before, but now with nulls. So I want to have a look at those rows where the value in the column value is null, and then I'm just having a look at the head. For example, here you can see, well, only on the value on the first rows of these rows that I have null values in row 0, 1, 36, 37, and 48, at least in the head. Of course, there are more. If you say the same but tail. Or if you say the same without anything. You see, there are a lot of null values. All these rows have null value in this column. And why is it important? Well, because we want to compare investment, and this is the investment. So we do not know what happened in some countries in these different years. Okay? And now the other thing that we can see eventually is that there are some countries that are not valid countries, right? European Union 20, this is not a country. European area, Euro area. So these rows, in fact, do not have representative information. Now, regarding Belgium, for example, we do not know what happened in the year 2006. In Greece, a lot. We do not know what happened in 2000, in Belgium in 2000. From Greece, we do not know what happened in 2006, 7, 8, 9, and 10, and 11. So for Greece, we have very few information. Also from Luxembourg. From Romania, just 2 years, and Slovenia, just 1. Okay. So why are we interested in that? Because we need to decide whether in our comparison, we are considering these countries, but only in the values they have, or if we are excluding these countries from our comparison, or we are treating them in a particular manner. Now, again, when we learn to process tables, there are a set of aggregation functions that are very useful when we do factual analysis also, right? So in Mongo, you saw it. If you studied relational databases, you also saw this. And so here, there's also a set of aggregation functions that can be used in order to perform analysis. So for example, I am asking for the maximum value in every column. Did I say copy? I don't remember. Yeah. So interesting thing. I am asking for every column, but look that it pivoted it, the maximum value. So for time, the maximum year for which I have information is 2011, which I knew because I knew this. For geo, it's Spain, and for value is 8.81. What happens with strings? When we have strings, the maximum value is evaluated with respect to the alphabetical order of the Latin A, B, C, D, E, what's that? The Latin letters. And then I can have things like that. Now, an important thing to consider is the max function excludes null values. Okay, so that's good news because we know on the actual values, right? With respect to this one, note that this is different to this. So the first one doesn't exclude the null values, whereas here it does. So let's have a look. So you see here, the maximum value is the one we have here, 8.81. And in using this function, the maximum value is null. So this one considers null values, whereas this one excludes null values. Okay, so depending on what we want to do, we can use either of them. Well, in a moment, I will give you time to go through the rest of the aggregation functions. What time is it? Okay, so we have 10 minutes. Just let me think how do I organize my time? Yes, what I will do is, well, I will give you time to complete. You will see that it's not very long, but and it's understanding the different ideas of how to deal with the operation. So I will give you the last 10 minutes of this session, and then let's say supplementary 10 minutes after the break to finish the exercise. I will be here. We can answer. I can answer questions, etc. In order that we move to a second exercise that I have planned to do with you. Okay, so I will let you finish. So I'm here, right? So now it's a question of operating on the content. Then you will have a data manipulation language when you add columns or rows to the content, and then at the very end you will impute values and perform the comparison. Okay, so first try of comparison, and then we will discuss whether this comparison can be useful to answer the research question. So this is the general thing that will happen in the remainder part of the exercise that you will do. I think that 20 minutes is enough for doing this. So as I said, I let you work the next 10. Well, let's do the following. We can work until 11. Then we do a coffee break, and then we pass to another thing. I think that that's the best thing to do, so that we have a big part on exploration, and then we have a little rest, and then we go to the last part of the morning. Okay, so at 11 we stop, and then we have a 10 minutes break, right? So I will stop sharing my screen, but well, you will see me because I have my video here, and so I let you go through the remainder part of the exercise. And I will stop recording because otherwise it will be my face only too. So I'm going to wrap up this exercise. If you haven't finished, you can do it later on your own. The important message here, rather than really finalizing the exercise, is the following things. First of all, as I said, in order to proceed to clean and to really have a comparative analysis of the data to determine whether they are comparable or not in terms of funding policies, the first thing to do is work the data set such that we can adopt an imputation strategy, both in general for dirty data, so for null values, but also, as you have seen, many of the rows contained in the data collection do not refer to actual European Union countries. So in a huge part of the exercise, what it's done, it's preparing the data in a way that we can start getting rid of those dirty data. So as you have seen, there are many Euro area 13 or 18, etc. strings that do not represent actual data. So the idea is to adopt an imputation strategy where we get rid of the records. Okay, so this is this is pertinent because it is impossible, according to the data that we have, to estimate the real values regarding these observations. So since there is no mean to guess which were the actual countries to which these values refer to, so the only thing that can be done is not considering them for the comparison, particularly because we are using statistical strategies that are, as I said, sensitive to this kind of analysis. Sensitive to dirty data for performing this kind of analysis. So that's the strategy adopted both for null values and for these countries. Then, of course, when there are values, if we didn't have the problem of the name of the countries, but only the name of the values, there could be other imputation strategies. For example, if an expert tells us that the missing values of some country can be computed out of the values of countries that have had similar investment policies in the same year, so we could perform other types of computations in order to estimate such values. And also, if we would have some previous behaviors of the investment of the same country but in previous years, then we could extrapolate the missing values. But this is only with the guidance of expertise, and we have in our conclusions to consider this and explicitly explain that these values were actually estimated and are not do not come from actual observations. And then at the very end, at the very last part of the exercise, what we did is we plotted the set of countries that remained after our cleaning procedure. And then there was a comparison per year. And two elements are important. So of course, and that's something that we insisted last time that we worked together, is that the results, the plots and the results of the different operations that you perform are not the answer to the research question. So this is very important, particularly when you will do your the project. Do not provide us the result, the plots. The plots just give you numerical arguments and data sustained arguments in order to drive your actual interpretation of those results to answer the research question. So in this sense, for example, first of all, as I said, we would have to declare the strategies we did in order to prepare the data. And the fact that we got, just kept a subset of the data of the countries that were represented in the data set. Then if we have also to say, why did we consider the whole spectrum of temporal interval that was contained in the data set, regardless to the fact that for some years we have more data for specific countries than others. So the data that we have among countries for every year is unbalanced. Okay, so we need to either to have another type of preparation, and if we didn't have such type of preparation, then calibrate our comparison with respect to this aspect. And then the third thing to consider is, of course, in the European Union, well, the idea is that countries are more or less homogenized in the kind of policies, particularly economic policies, that they apply. But in fact, the situation and economic situations of different regions of the European Union are different. So maybe this comparison is too idealistic, right? So maybe a better way of organizing or of interpreting the comparison would be to consider different regions of the European Union with countries that are economically comparable, and then perform our comparative study per region of the European Union, and not considering a very homogeneous understanding of the different countries in the European Union. Okay, so these are the aspects that, of course, we can rely on the plots, but then perform a more intelligent and accurate analysis with respect to this kind of knowledge that, well, we have, because we are more or less educated on the way the European Union works. But if we didn't, we would have to go to economists and experts of the European Union to provide us with complementary information so that we could perform our interpretation. And then at the very last part of the analysis, many practitioners of data science, particularly today, recommend, once we have done this kind of script specification of an experiment, to try to extract the actual workflow that is implemented behind this script, such that we have a schematic organization of the different phases of the experiment, and this to allow us or other people to have an overview of the experimental setting and eventually reuse it, modify it, or reproduce it. Okay, this is for reproducibility issues. You have to know that more in academia than in commercial solutions, but this thing is moving towards the fact of providing a system, the script, and then the system will generate the workflow. Okay. For the time being, it is up to us to do that, and this is a best practice regarding experiments, so that we can also reason about the experiment in a more schematic manner. So here you have an example of a textual description of the workflow of this exercise done by one of your colleagues of the previous years. But it could be also interesting to have really a figure, you know, to show this in a more metaphorical and representative manner. Okay, I mean, there might be some technical issues that you will face while you execute the exercise. I suggest that you contact me, I mean, outside the course if you have such kind of problems, so that we can move on to the next exercise and not consider particular technical issues regarding the language, etc., that you might have. I'm assuming, of course, that you are not Python expert programmers, so I mean, this can be normal to have little issues that we can solve eventually, but the idea is to consider what I have said beyond the language, particularly also because the remainder of the course will be done using R and not Python, and we are just having a little look on how those Python solutions look like in a way very similar to R solutions. If you are really curious, another thing that you could do is reproduce, for example, part of the exercise and use Kaggle, but using R, create an R notebook and then use it with R code. That's also a way of capitalizing on the aspects that we are seeing today regarding Python.
Is there a specific thing to do to use R with
No,
Kaggle?
let's try it. So we would go we would go to code.
Code. Yeah.
Then you create a new notebook. And then you go to language.
Okay. Language.
And here you choose R.
Okay. I see.
And then you work as normal as in RStudio, but here.
Oh, yeah. Okay.
Okay.
And how to save what we did?
It's already saved.
Oh, okay.
This is the magic of of the cloud. It's continuously saved. And then if you want to share your notebook, what you do is you click on share here in the upper part, and then you put it to public, and you can share this link. Well, now it's not saved because I haven't done anything yet, but in the previous one you can proceed as, and then let's consider that you share it with me. So you send me the link, and that's it. You can also declare me as collaborator. And in that case, I will know that I am a collaborator, and I can directly on my space see your notebooks. So if you have, for example, technical problems, you put me as a collaborator, I know, and then I go and I have a look at your problems directly.
Okay.
Other questions?
No, so far.
It's cool, no?
I don't know what happens with the chat, but I cannot copy your code.
No, Because and yeah, that's a thing I forgot to consider this. What I will do, did I share a Slack with you or not? I didn't, right?
Did you share what?
I didn't share a Slack code. So I will send the piece of code on
Okay, look,
on mail. Yes, I realize that this is an institutional Zoom link, so
okay.
there is no possibility. I can share with you the things, but it's not possible to copy.
Okay.
But I'll put that on mail so that you can do the exercise, and then and I will even put a comment on Kase when this will be available so that you can make sure that this is the right code. Something else before we move on? Sorry. I want to share my chat. We are going to change tool so that with the next exercise, you also have the experience on Collab, which is an alternative tool to Kaggle, okay? So this is why I'm making sure that for the time being, there are no questions so that we can move on. Okay, so what I'm going to do is the following. So I'm going to close no, I'm not going to close. I'm just going to move them here forward. And this one I'm going to close. And I'm going to share this link with you. And I'm also going to restart no, so I think it's registered. Okay, so that I don't forget. And so I'm going to share this with you. Oh, where am I? Here. So this is the link to the second exercise on the chat. And the second thing I'm going to share is the link to Collab. So as I said, we are going to move to Collab, and I'm just going to open my, right, okay. No. Sorry, I'm going to stop sharing because I cannot see my full screen, and just a second, and I'll come back. Just a little second. I'm almost there. It's not what I want. Sorry. This, okay. I'm almost there. Oh, yes. First, I am going to share the following thing with you. Okay, I'm going to start sharing screen again. And I'm going to show you something. I'm going to show you how experiments can be shared with using GitHub. Since we are in this so the last link that I have shared goes to this environment. Well, this is again something that it's the same exercise that we have performed today. No, this is another exercise. But anyway, the idea is that once you have your notebooks, you can create repositories on GitHub in order to share them and ready to be executed on the equivalent environment that we are going to use as alternative to Kaggle, right? So in Colab. And so if you click in Open in Colab, wait, more or less a little bit of seconds, and this creates a copy of your of the notebook in this Colab environment. And now using this, I'm going to introduce you to Colab, and then we perform the exercise. Now, if we go back to the back of the scenes that I used to describe our lab, we would continue to have this as repository, but now we are storing two things. We are storing data, and we are also storing some notebooks that have been already done by someone, right? On the other side, we continue to have a similar setting on Google Cloud as we have been using, but instead of using Kaggle as a notebook running environment, we are going to use another service called Colab, also from Google, by Google, okay? And the setting is the same. We are going to import the code this time to Colab, and then we use the browser in order to access our execution environment. Now, some particularities about this service is that when we use Kaggle, we have new storage space for our data and our notebooks, etc. When we use Colab, in fact, this is a service provided as for us as users of Google, okay? So we need a Gmail account. And you remember that when we create an account on Google, we have a storage space on Google Drive, right? So it is going to associate our Google Drive space in order for us to have our data sets and our notebooks, okay? So the amount of storage that we have is determined by the type of subscription that we have in Google. And of course, we are sharing with all the rest of our files, so we have to be a little bit careful, because if we do an unglorious manipulation, then we kill our data, right? We can also have access to infrastructure, either on the cloud or locally. So we can have a virtual machine or a cluster on our organization and connect it to Colab. So that's a particular aspect of Colab, which is a little bit more technical, but this can be interesting for those that do not want to completely externalize the whole execution of the experiments out of their organization. So you can have a hybrid solution, cloud and organization for your experiment. As I said, the storage is Google Drive, or also a local disk that we might have available, okay? And then, of course, the most interesting thing is that we have all the interpretation environment there, so we do not have to install anything or maintain any version of our libraries, etc. Okay. So I'm going to close this and I'm going to go back. Now, if you click here, you will see that well, it's less user-friendly than the other one, but it's also very interesting. So as the other solution, Kaggle, you start with your notebook. In this case, we have an already done notebook. Here to the right, you have the environment, the running environment that you have associated to your experiment. So if you click here, you see that you have many different things. When we open a Colab session, we are allocated with a virtual machine with certain characteristics. You can modify the type of execution. You can modify the environment. If you have a virtual machine of your own, you can associate it to it. What else? Well, and then you have all the control of the resources that you are consuming. And then as in Kaggle, you have here you see here we have allocated a machine with that connects to that has installed Python 3, and these are the RAM characteristics of the machine and the disk. So I have a lot of disk. This will change depending on your Google account. So that's execution environment. And now to the left, you have in the bottom part of the bar, you have a file. So if you click there, you see that you have many options. You can upload files from your local space. you can update, of course. And here you have connection to your Google Drive space. Okay, so if you click here, it provides you with this code. You are a little bit young, I imagine, but some years ago, when you added a disk or a hardware element on the computer, you have to mount, particularly this, you have to mount the disk so that the operating system can see it. Okay. That. So here we are doing this procedure in order to mount the our Google Drive space to this environment. Okay. So if you click to your Google Drive space, you will have to grant accesses, so follow the instructions, and then it provides you with this. Once you have granted access, it provides you with this code. So if you execute it. So you see, it asks me whether I want to connect to Google Drive. I will say yes. I will connect to my account. I grant a lot of things. And then I wait a bit. And now in some moments, you see, I have my drive. And in my drive, well, the drive, a folder drive, and inside my drive, I have my Google Drive, and well, I have many.
Sorry, Genoveva, do we grant all the authorization for
Yes, yes, all.
Okay. I cannot see the drive. Not yet.
It takes a while, so
Oh, yeah,
if
yeah,
you,
yeah.
and then you have your drive.
My drive. Okay.
And then what it contains. Me, I have other computers and blah, blah. Okay. Now, second line. Well, that's access to your drive. Me, I'm interested in doing that because I want to use other notebooks, and they are there. Okay. Then we need to do the first step, which is this one, right? We have to get the data from GitHub to here. Okay. So this is done now. As you can see, this is more technical. It's less user-friendly than the other one. Here you need to execute code. So here I am saying that I am executing a JIT function. So when you have an exclamation mark, this means that this is not Python code or R code, the one you are using here. This says that it's from the, I'm doing an external call, right? So I'm telling JIT to clone the content that resides here. Okay. So if you execute this, it will take a little bit time. And now you have the clone of this, right? So it's NC3 because I used to only teach it at NC3 and not with EGI. And then you have again something that you already know, which are the files, right? All clear? All the time? So it's more or less the same principle, but with a less friendly interface. However, this, I mean, it's a very popular tool nowadays.
Does it take time to
Yes, a
clone?
little bit of time, a little bit. But if you don't see it, you click and then back, and then you will see it.
Okay.
Mhm. You can also click here to refresh.
Oh, yeah. Okay. It appeared.
Mhm.
Okay.
Okay.
Yeah. Well,
Now I'm going to find a new one. I'm like I'm hesitating. Just give me a second. Yes. Now, what I'm going to do, I decided otherwise so that you can have like an alternative of, I mean, you are acquainted with statistics, so I don't think that statistics is a super new thing to do, but I think that this is a more interesting thing to do. However, you will have to listen to me a little bit before before we can do this. So I'm going to share this on chat. Since we are doing data preparation, so in the first exercise, we just did imputation of null values and of the values, okay, of the records. With the most easiest way to impute data, which is getting rid of the data. Okay, so that's the easiest way to do. We can discuss whether this is the best thing to do, but for the exercise, it was good. Now, the other aspect that I referred to in regarding data preparation was outliers, okay? And now for outliers, of course, it is possible to perform a more manual and a more statistical analysis in order to try to identify, I mean, values that are out of the distribution of the values of each attribute. But this is a kind of more yes, manual thing to do. And so there are other techniques stemming from artificial intelligence and particularly from machine learning models that can allow us to identify outliers. So I'm going to introduce a way of doing this using a clustering technique. Okay, so that's what I'm going to do, and in order to do that, I'm going to have a very quick introduction of machine learning and the kind of technique we will perform, and then if there's time, we will perform the exercise together. Otherwise, you will perform it on your own at home. So in order to do that, I have to stop sharing for a while so that you can see my so that you can see my other screen. Okay. So I just have to open up file. Just a second. Come. I think that someone, a very young,
Ça va être simple.
a very young student is with us. Okay, so back to sharing. Pass on this. Yeah. Okay. So in order to use this machine learning technique, I'm just going to introduce a bit on machine learning so that you can put in the right reference the technique we're using, right? So of course, learning is a kind of a question. So we want to acquire knowledge or skills, or we want to acquire knowledge by studying experiences, etc. So in fact, it's out of experience of this idea of acquiring knowledge and learning out of experience that the whole philosophy of machine learning is based on. Okay, so the idea is that we are going to provide an algorithm with enough input about some experience and about some observations, and we are going to parameterize variables in a probabilistic or statistical manner, such that we produce a representation of our observations, statistical representation of our observations, such that we can say that the algorithm acquires the knowledge of some set of observations, and then when new observations can come, the algorithm can be the model can be able to classify or to identify these new elements according to the knowledge that it has acquired. Okay, so this is the general principle. And you must know that there are different techniques according to the way we acquire this famous experience, okay? So, and these are different families of techniques that allow us to use these models. The first one is supervised learning, which means that we have the experiences and the conclusion. We have this knowledge. We have, for example, a set of physiological values, and we say that the person has contracted diabetes or not. And another set of physiological values, and no diabetes, diabetes, no diabetes, diabetes. And these represent the knowledge of a domain that has been validated by someone, okay? And then you are going to use this knowledge in order to identify some pattern such that when new data come, new physiological variables come, it can be possible out of the experience to know whether or to estimate whether a person will contract diabetes or not, okay? Which is more or less what physicians do for diagnosing the diseases, right? So they base their knowledge on previous cases, and then they study a set of input variables that are representative to for detecting some diagnosing some disease, and then out of their knowledge and the variables that the input that they have, they estimate whether a specific diagnosis, okay? So the same principle with this type of algorithms. And there are many tools and algorithms in order to perform this kind of knowledge extraction, this kind of analysis. And one of them is, for example, a lot of regression. Okay, so in the next, not with me, but in the next part of the course with Professor Jolie, you will study this kind of algorithms and techniques. And the opposite of in the spectrum is unsupervised learning, which means that you have observations of a phenomenon, but you do not know anything about any conclusion. You just observe elements. And then you try to model the behavior of that phenomenon by looking for patterns that can give you insight on the way this phenomenon works. Okay. And there, many solutions are based on clustering. Okay. And this is again a way inspired on the way we learn as humans, right? We observe, identify patterns, classify the patterns, and then drive conclusions about what we observe. Okay. Which can be problematic in some aspects, but well, this is the way we acquire the complexity of the phenomena that we observe in the world. Okay, and so this is a second family of techniques, and then the third family of techniques is that we acquire some knowledge, and then someone will reinforce our observations, our insights or not. Okay, so we drive a conclusion, and then externally something reinforces or not our conclusion with respect to a phenomenon. This is, I mean, in a very caricatural manner. Of course, every family would require a complete course in order to really be studied, but these are the general principles of the families. Reinforcement learning, the most popular solution now is ChatGPT. Okay, if you have been using ChatGPT lately, you ask a question, it provides you with an answer, and you say like or dislike. In fact, you are participating in the reinforcement process of the model. If you say like, then it knows that that it has performed well with respect to the expected your expectations with respect to the question, and if it has performed bad, it calibrates itself such that in order to reduce the problem. Okay, the problem which is not being precise with respect to the answer it provides to a given question. And so we are going to concentrate on supervised learning to apply a clustering technique in order to identify outliers in a data collection that we are preparing. Okay, remember that we are always remaining in the zone of data exploration and preparation, at least with me. Then you will perform the other part. Now, the objective is thus to find hidden structure in unlabeled data. Problems that can be solved is classification in general. You can use it also to reduce dimensionality, okay, to find which are the actual variables that that are representative with respect to an observation. That's also an application of unsupervised learning, outlier detection, or a novelty criteria. Okay, so that's the kind of problems that can be tackled with unsupervised learning. Now, if we zoom on clustering, which is the technique that we will use in the exercise, well, the idea is kind of simple. You are going to consider some classification criteria. I will introduce those that we are using for a particular algorithm. So you consider these criteria as classification criteria. Okay, for example, if I'm classifying people, I can classify them with respect to their nationality, their age, their gender, and their professional skills and their salary. Okay, so these for me are the variables that allow me to classify people. Okay. So, And then once you have this, you will try to, given a data set, to put similar items of the data set in classes, in groups. And once you have a first some try on this classification, you have measuring scores that allow you to identify whether this classification is of good quality or of bad quality. And essentially, any classification and clustering technique searches for classes in which the items belonging to a class are close enough among each other so that they do not remain in the periphery of the class. And the second parameter is that there is a frank difference between two classes. Okay? The distance between two classes is far enough in order to make sure that they really separate the items in a contundent manner, right? So that's the general principle of the way clustering works. Now, so the three aspects to consider is how can we group the samples, so which are the variables that we will consider in order to do that? How many clusters is the good number of clusters? Do we know it a priori or not? And then what constitutes a good group? So these are the three metrics that we have to, and the aspects that we have to consider in order to perform classification. Now, before I go there, now let me just yes, yes. Well, I'm not going to well, I'm going to use this, but I will explain in a friendly manner, not in a mathematical manner. Then you can have a look at the mathematical manner. We are going to use a very popular algorithm for clustering called k-means. Okay, so the principle of k-means is the following. We are going to consider that our observations are, as I said, records of variables. If you consider a record of variable, you can associate these records to a vector, a multidimensional vector, belonging to a multidimensional space, where every dimension of the space is represented by a variable. Okay? So if I have gender, age, and income, my space will be a three-dimensional space where I will have three dimensions: gender, age, and income. And all the observations that I have regarding these three variables are vectors within this three-dimensional space. Okay? Three value vectors. Okay. And of course, if I have more, well, I have an n-dimensional space where I can position my vectors, which are the observations contained in a data collection. And then I'm going to do the following. I'm going to choose, using some strategy, vectors that I consider representative from the data collection. If I have a queue, I have enough knowledge, I can perform some strategy or say in an intelligent manner, which are these vectors. Otherwise, I can use a random criteria. And so out of the vectors of my space, randomly, I will choose some representative ones, okay? And I'm going to call them centroids. Then for every centroid and for every the remaining data collection, I will compute the distance between every element in my collection with respect to a centroid. If these two vectors are close, using, for example, an Euclidean distance, then I will consider that they belong to the same class. And if they are far, they do not belong to the same class, which means that I have to define a threshold saying in which cases, to which extent I consider that two vectors are close or far. Okay. And once I have done this with every centroid and every element of my data collection, I will end up with clusters, with classes. Okay. And once I have my classes, I can determine which is the quality of my class. And so I can say how close are the vectors within a class with respect to the centroid. If they are very close and very compact, this is a good quality of class. And then I can compute how far are classes among each other. And if they are far enough, I will consider that this is a good classification. And what happens with those elements that I cannot classify? I will suspiciously say that these elements can be outliers. Okay? Questions? Very easy. Now, the problem with this algorithm, I mean, it's kind of intuitive, it's elegant, it's very interesting. I use knowledge that I know from forever, Euclidean distance, vectors, multidimensional spaces, thresholds. So that's kind of elegant. But the problem is that computationally speaking, this can be very costly because I never know how many loops I will perform in order to define my class, which is the good number, for example, of centroids. The number of centroids will define my number of classes, right? And which is this number? Well, I don't know, and this creates a little bit of costly aspects. So in the implemented solutions, what it is done is that you have a guess on the right number of classes that you are seeking for. And so with this number of classes, you make a deterministic number of clusters that you are seeking for. And then if you are not happy with that number of clusters, then you re-execute with new number of clusters, okay? And so this reduces the uncertainty of the algorithm, but the principle is the same. Now, some particular things that remain a little bit obscure is the criteria to either define the number of clusters or to identify the centroids. This can be done, as I said, randomly, or this can be decided together with an expert. Okay, if there's expertise around, experts normally can tell you potentially which would be a reasonable number of centroids or of clusters. Again, if nobody knows, then you perform a lot of tests, okay, of tries. Second thing, which are which is the right threshold to determine whether two vectors are far or close. Again, this is very well, this changes according to the type of observations that we are making. So again, this can either be proposed by some expert or, again, by trying a lot of possibilities. And finally, regarding the scores, normally in the libraries that you have and the practices that you have around k-means, you can know which are the good numbers, I mean the good values, to determine which whether a clustering solution is fine or not. Okay, so that's given by the domain. Okay. So questions until here?
No.
No? It's very, I mean, it's very intuitive. That's why k-means is also a way of a good way of introducing clustering in general, and you will see that it's also very useful for
maybe one question is you didn't mention if choosing randomly or not lead to same kind of precision results or something.
You don't know. This depends on the application. And
okay.
you see, and this is why, well, first of all, using the computer is interesting because this can be automatized. So the tries can be automatized, and then you can perform, for example, in your tries, you can have like an statistical decision making on how you are going to vary the different variables. Okay, so that you do not perform like crazy numbers. You define some kind of distribution of the values of your parameters, and then you vary in a smart way, either the distance, either the number of clusters, or the two of them.
Okay. Okay.
Now this remains, well, the main critic of in general the practice of machine learning and artificial intelligence methods is exactly this, that there is some part of artisanal. I didn't open my camera, sorry. There is an artisanal practice somewhere that makes it well, interesting, but also costly in terms of the number of tries, and also, well, it is experience that people acquire in order to have a flair in the way they calibrate the algorithms. Otherwise, today there exist automatic techniques in order to calibrate this without, I mean, with few knowledge of the domain, which is also a big critic because this requires a lot of resources, and resources represent either money or energy. So, okay. Now, I'm going to introduce the exercise. We're not going to do it together, but I'm going to introduce it to you so that you can perform it. What you will see is that I will provide you, well, the gist that we opened is in fact the result of the exercise. So to prevent you from spending time in implementing it, but rather understanding it, what I'm going to do is I will send, and I will share also online the gist address, and I will let you observe and ask you some, point you on some elements to pay attention on instead of implementing it, right? So that you can concentrate on the project and the next part of the course rather than on the exercise, which is more introductory than other thing. Now, a good and maybe an interesting thing to do is that in the project that you have to do, you will have to identify outliers. So maybe a fancy way of identifying your outliers could be to apply the k-means algorithm in order to do that. Right? So that would be an interesting thing to do. Now the exercise is divided in 2 parts. The first part, in fact, introduces about the different indices that allow you to assess the quality of a cluster. Okay, so that's first part of the exercise. Well, it's also a way of showing that behind any artificial intelligence algorithm, there's probabilistic and statistics, okay? And sometimes matricial reasoning, okay? So having a good basis on this kind of knowledge allows you to step into this kind of solutions in a very smooth manner. So that's, as you can see, well, there are a lot of tests with respect to these assessments. And then what I want to do, then it introduces the algorithm, but as I have introduced it. And then let me introduce the research question, which comes later on. Yes. So the research question is the following. It is again a Neurostat data analysis. And so the idea is that it illustrates the way members, again, more or less what we have done, it's members of the European Union perform investments, right? So in private, in public, and GDP, so gross domestic product, and including education. So it's more or less the spirit of the other data collection that we used. And then the idea is to classify, okay? So to follow up to my observation with respect to our first experiment, the experiment was, okay, I consider everyone like behaving in the same manner. Here, the idea is to group different countries of the European Union according to their economic practices in order to find those that are similar among each other, and do not consider that everything behaves the same, all the countries behave the same within the European Union. And those that we cannot classify, then we can see, in fact, remember, it's not that they are actual outliers, but I can suspect that these observations are outliers, and then I would have to perform some imputation on them. So that's the principle of the exercise, and that. So as I said, what I will do is I will share, in fact, this gist. Okay, so the gist that I showed you as example is the solution of the exercise. I will give you that. If I really have time, I will produce the R code because in that case you would, I have bad connections there. If I manage to do that, then you can use it for your data, okay, for the project. So I will really try to do that, so that to encourage you to use it for the other project, right?
That's fine. Fine.
So that will be the part that that I will do, and then with that we can wrap up saying that it is possible to externalize. It is possible to define different execution environments to perform experiments and compare them under different conditions, and that there are two main problems to address in data preparation: is determining the quality of the data with respect to null and missing values, and then having techniques to identify outliers and propose an imputation or several imputation strategies in order to prepare and clean the data such that it can be ready to perform any other kind of analysis. That's in a nutshell what we have done today. And with this, I am going to conclude. Of course, the floor is open if you have questions about anything we have discussed.
I'm afraid no.
It's good. I mean, if there are maybe questions will appear when you will have a look at the exercise.
Probably.
And then eventually, if you decide to apply some of, I mean, particularly this clustering technique in your project, and you have questions, do not also hesitate to contact me and ask me if you need some hints. I will be happy to provide.
No, the only question that we may have is, for example, determining or figuring out when an outlier is a real outlier or not. Means that what I understand is that we try to fit the model to, or fit the distribution of data to the model ability to deal with it.
Deal with it, yes. In fact, you have to have different tries. First of all, you classify and you make sure that your classification has good properties, okay? Because this means that those that you couldn't classify are really those that are problematic for some reason, okay? So that's first thing. Then once you identify the problematic elements, then you must have a study on them. Okay. And have a look what are their properties, and eventually refer to the application domain in order to consider whether they are real outliers or not. For example, I used to have a project on energy, right? And so we wanted to observe the behavior of energy in houses. Okay? And at some point, we perform this type of classification, and we have these outliers, meaning that we had observations where energy consumption was particularly low, really particularly low. And then others that was particularly high, right?
Yeah.
And then what we observed is that in some cases, this was not an outlier, but it was the period in which people, for example, left for holidays.
Yeah. So it's part of data. So it's part of data.
This was the right data, right? The only thing was that since it didn't go, these were particular moments and not a kind of long period behavior, we they couldn't be classified, right?
I see.
So, and there, well, it's just really having a look at the problems and trying to understand also with respect to other data, particularly knowing that the behavior of people along the year, right?
Yeah.
And then there were others that were really a problem of the sensor, right? So the sensor was working bad and it was producing like data nonsense.
Crazy, yeah.
But and why? How did we know it? Because they were very close to the others. The only problem with respect to specific to the other variables that we consider to classify, but it was the value that was having problems. The reading, right? Whereas the other properties were close to the crowd. Okay, so in that way we knew that these were anomalous readings. But then you really have to go to the data directly. There is no other way of identifying them. But at least it's a subset. You're not going to go record by record analyzing everything. It's just the particular cases that you have to observe.
Okay. And is PCA giving a first a view of this or not? Is PCA able to?
This is also possible, yes.
Okay.
I mean, K-means is just an example, but there are other, particularly PCA, that can give you a hint on this.
I see. Okay.
And then you are like a doctor, right? You have to have different observations, different ways of having a look at the problem in order to have enough elements to argue and decide.
Okay. See.
Which is again something that it's important that you do in your experiment, in the project that you are going to perform, right? It's really showing that you use evidence to drive conclusions. That's important. More questions?
No.
No?
Not at this stage, I'm afraid.
Well, yes. Then eventually, if other questions come, then
Sure.
as I said, do not hesitate and contact me, and I will try to hint you to the answers.
So in the next stage, you're going to send us
Yes, I will. Now, agreements between you and me is I'm going to make sure that casein can liberate the content. This is my problem, that it doesn't liberate the content that I have associated to it. So I will solve this. If not, I will provide an alternative source so that you can have access to the material. And I will share the gist of this exercise so that you can have a look at it. And this is a weak agreement. If I manage to do that, I will translate it into R so that you can eventually use it in your project.
Okay.
And a fifth that I haven't said is that there will be questions in the exam. So in order to help you to prepare for the exam, I will provide control questions so that you can prepare and know.
Yes, that will be fine.
To guide you to how to prepare my part.
Okay, that's fine.
Very good. So I thank you for your attention. It was a pleasure to work with you these few sessions, and I wish you all the best for the remaining part of the course.
Thanks a lot.
Bye-bye.
Bye-bye.
Professor.
Bye.
Bye.
Can I steal 5 minutes?
Bye, Professor. Thank you. Bye.
Bye.
Professor.
Yes.
Can I steal 5 minutes before you leave?
Yes. Let's wait that.
Bueno, yo también soy mexicana.
Hola.
¿Cómo está?
Mucho gusto.
Mucho gusto. Quería hacerle una pregunta.
Sí.
Voy a tener una entrevista para una posición de Business Analyst.
Ok.
Y es en la parte el puesto se llama Supply Business Analyst. Y pues obviamente es para una internship, pero quería preguntarle si, no sé, quizá algo que pueda decir que me pueda dar un boost en la candidatura.
¿Tienes el perfil aparte del nombre del puesto?
Sí. Sí, aquí lo tengo. Un segundo. Ya voy porque no lo tenía abierto, pero... No quiere abrir. Ah, ya. Es... Es este.
Strategy. Bueno, con respecto a la parte de, digamos, o sea, la última parte que dice Data Management, por ejemplo, bueno, ahí puedes decir que el máster te está dando elementos y que, bueno, estás, o sea, que tienes conocimientos ya de preparación, limpieza de datos, por ejemplo. Si tienes conocimiento previo en data reconciliation, por ejemplo, en relacional o algo así, también puedes decir. Y eso te puede dar también lugar a tener bueno, ahí depende de qué tanto conoces relacional. Hay soluciones para relacional que te genera reportes, ¿no?
Ok.
O que entonces podrías, si tienes ese tipo de conocimiento, decir que, o si no lo tienes, decir que tienes suficiente conocimiento en bases de datos clásicas, como las relacionales, y también en preparación de datos para poder contribuir a algo, asumiendo que también el internado es para aprender, ¿eh?
Claro,
No,
claro.
o sea, no estás pidiendo un trabajo, estás pidiendo un internado. Entonces, en el internado es posible. O sea, yo lo que más haría en lugar de decir que sabes mucho, es decir que tienes los fundamentos que se requieren para entender
Claro, para
el
desarrollar.
contexto y entonces que es, bueno, puedas realizar un buen internado. Y
Súper.
luego en soft skills, bueno, puedes hablar de tu dimensión internacional, o sea, el hecho de que
Ok.
vengas de México, pero estás estudiando en Francia, bueno, hace que esa parte de internacionalización te facilita trabajar con grupos diversos, por ejemplo. Y eso es también importante.
Ok.
Y bueno,
Súper,
ya.
súper. Muchísimas gracias.
No hay de qué, ya me dices si qué pasa.
Claro que sí. Muchas, muchas gracias.
Con gusto.
Buen día.
Bye.
Bye.